Have scientists created life? This video explores the fascinating advancements in synthetic biology, examining how researchers are manipulating DNA and building complex biological systems in the lab. What does it truly mean to create life? The definition spans from synthetic assembly and cloning to modifying existing organisms or attempting to reanimate dead cells, each presenting its own unique scientific challenges. To understand the creation of life, we must first define it. Life is typically characterized by metabolism, the ability to reproduce, the capacity for evolution, and responsiveness to the environment. The theory of abiogenesis explores how life might have first emerged on Earth. It looks at the conditions of our early planet, chemical evolution, and the rise of the first self-replicating molecules. The famous Miller-Urey experiment simulated the early Earth's atmosphere. By applying electrical sparks to a mixture of gases, researchers demonstrated that essential building blocks like amino acids could form spontaneously. The RNA world hypothesis suggests that RNA was the precursor to life. Unlike DNA, RNA can both store genetic information and act as a catalyst, known as a ribozyme, to drive chemical reactions. Science has made significant strides in creating simple artificial structures, such as lipid membranes and vesicles, which serve as foundational components for artificial protocells. In 2010, Craig Venter and his team made headlines by synthesizing a bacterial genome. By creating a synthetic version of the Mycoplasma mycoides genome, they pushed the boundaries of genetic engineering. Is this a truly synthetic organism? While the genome was designed and assembled from scratch, it required an existing, living cell to host the genetic material, sparking debate over the definition of synthetic life. Today, we can synthesize entire viral and bacterial genomes. The field is rapidly evolving, moving from simple designs toward the potential creation of increasingly complex biological systems. Synthetic biology offers immense potential across industries. From developing new medicines and vaccines to engineering bacteria for insulin production, or creating sustainable biofuels, the applications are vast. Can we create a cell completely from scratch? Not yet. While we can integrate synthetic elements into living cells, de novo synthesis of a fully functioning life form remains a major scientific hurdle. Modern biology still faces profound challenges, explaining the origin of the first genetic information, the emergence of the first metabolism, and the start of self-replication. Despite the limitations, we have achieved significant milestones: the design of complete synthetic genomes, successful transplantation of this DNA, and the creation of functional, self-replicating organisms. In conclusion, while scientists have learned to design and modify life, we still cannot definitively recreate how the very first spark of life began on Earth. The ethical landscape of synthetic biology is complex. As we gain the ability to manipulate life at a fundamental level, we must carefully consider the moral implications of our scientific power. Safety and security are paramount. With the creation of novel biological entities comes the responsibility to prevent misuse, whether through accidental release or intentional harm. What does the future hold for this field? Continued research into synthetic genomics could lead to breakthroughs in medicine, environmental protection, and our understanding of life itself. We are standing at a crossroads. Every advance in synthetic biology brings us closer to answering the age-old question of how life began, while challenging our concepts of existence. Thank you for watching this overview. Understanding these scientific developments is key to engaging in the ongoing global conversation about the future of synthetic life. This video is supported by a comprehensive list of resources, including scientific literature on abiogenesis, synthetic biology, and the fundamental origins of life. Our bibliography features key works like The Vital Question by Nick Lane and The Fifth Miracle by Paul Davies, alongside essential publications from authors like Craig Venter. Scientific articles such as the seminal Miller-Urey study from 1953 and more recent research by teams like Gibson et al. Form the foundation of our exploration. We also draw from authoritative online sources, including NASA Astrobiology and journals like Nature and Science, to ensure the information presented is accurate and up-to-date. We hope this resource list encourages further personal research into the fascinating and rapidly evolving world of synthetic biology.